Hi, it's Miss Reese, and I'm going to be showing you how to use the Desmos Slope Ratio tool to help you solve for missing sides in right triangles. So you can type this into your browser, or maybe there's a link on Canvas for you. I have a link right here on my Canvas. So I have the Slope Ratio tool open. We have a specific angle. You can see here, instead of calling it theta, it's called alpha here. So we have our slope angle. Right now it is set to 45 degrees. You can type in different angle measures. You can also use the cursor to increase the angle. So notice as we increase the angle, our change in y increases and the ratio between the sides increases. So this ratio number here increases as well. So I'm going to put that back at 45. So what we're going to look for first is we are going to look for the slope ratio for a slope angle of 28 degrees. So let's go ahead and change this to 28. And I'm just going to type this in. It'll be a little faster. Type that in as 28. And we get a slope ratio of 0.531. Actually, 531 is going to round to 532. The number after it is a 5, 6, 7, 8, or 9. And we typically round to 3 decimal places. So we're going to do 0.532. And actually, I'm going to go ahead and solve the problem right below. So what we know is that in a triangle that has, or in a right triangle that has a 28-degree slope angle, the ratio between these two sides, what I get when I divide them, is going to be that 0.532. So I can set up a ratio like this. I can say y divided by 12 is equal to that decimal 0.532. I like to put this over 1 just so I can remind myself that I'm really kind of doing a cross product here. I'm trying to solve for y. Y is going to multiply to 1, so we're going to get y equals, and then we're going to multiply 12 with this 0.532. So I'm going to show my work for this. Y is my cross product, y times 1, and then we're going to multiply 12 times this slope ratio. And let's get our equivalent value. Let's open up a Desmos Scientific, or actually I'm just going to open up a calculator off to the side here. So I'm going to do 12 times 0.532, and that's going to be 6.384 is what that approximately is. And I'm going to put approximate symbol here because I rounded the 0.532, so it wasn't an exact answer. Okay. Let's look at, or put this back to our triangle here. And I'm going to change this to a 12 so we can see if we can actually make that triangle perfectly. So I made that side a 12. And you'll notice here that I've actually created a visual diagram of this triangle. We have the base here as 12. And then we have our side length here, which is the 6.38. I said 381. And so because we rounded that 0.532 a little bit, this is just rounded off slightly. But you can see here you have a visual representation of that triangle. Let's go to the next one. We have a 50-degree angle. So let's change this to 50 degrees. And we know that when in a 50-degree triangle, when we divide our change in y with our change in x, our height with our base, we are going to get this ratio here, 1.192. 1.192. So let's write that decimal. And I rounded that again. So you can put, if you want to, you can put about 1.192. It's not exactly 1.192. I'm going to put about for those. So I know when I take this 22 side and I divide it with x, so 22 divided by x, I'm going to get that decimal, that 1.192. I'm going to put that over 1. Now this time, when I set up my cross product, I'm getting x out of that denominator, x is going to multiply with that ratio, that decimal. So I'm going to get 1.192x is equal to 22 times 1, so 22. So for this time, in order to get x by itself, or in order to isolate x, we actually need to divide by that ratio on both sides, 1.192, and divide by 1.192. So then your final solution for this, you're just going to go ahead and type this into your calculator, 22 divided by 1.192. 2. And that's going to be about 18.463 is what, or 456 is what I got. And the number after 456 is a 3, so we're going to leave that as 456. Okay. You're going to go ahead and try this last one on your own. So open up the slope ratio tool, okay, and you're going to change this to a 56 degrees. Write down that number here, and then you are going to be able to set up your ratio for this. Remember, we've got y over 10, and then you're going to set it equal to that decimal, whatever your decimal is. And I'm going to put that over 1, just so that we can always create a ratio here. Okay. Now for the rest of this page, you're going to be doing the same thing. We're just practicing with making sure we can use our slope ratios. So again, it's going to be like y over 16. Y over 16 equals, we need the ratio for 22 degrees. I'm going to put in 22. And that ratio here is 0.404 is what we're looking at. So 0.404 over 1. And so this one, your cross product is going to be nice and easy. The y is going to multiply to 1. 16 is going to multiply with 0.404. Try one more kind of set up together. Remember, it's always change in y over change in x. Height divided by base. So we're going to do 18 over x for this one. And in order to figure out what we're setting it equal to, we need to know what a 66 slope ratio is. So our angle for 66 gives a slope ratio of 2.246. 2.246. And I'll put that over 1. Now you might start to notice something here. When x is in the denominator, let's do our cross product. Do you see how it gets multiplied by our ratio there? In order to get it then by itself, it needs to be divided. So we've got 2.246 times x is equal to 18 times 1, 18. So anytime you can kind of think of this, anytime your variable's in the denominator, you're going to end up dividing that ratio into the side length. So we're going to divide by that 2.246 on both sides. Divide by 2.246. So think denominator. My shortcut, I kind of call it denominator, end up dividing the ratio into the side. And then for this one's set up nice and easy. Our y is just going to be multiplied to 1. 16 is going to be multiplied with that 0.404. And I'll let you put that into your calculator to get your final solutions for that. And that's all you're doing for questions, question 3 here and up through this page as well. So I'd like for you to pause this video, and I'd like for you to try all of those problems first, because it really will help you get a sense of what we're going to be moving on to next. Okay, hopefully you paused the video. You have now solved all of the questions up through J. Now I feel that we're ready to kind of move on to the next part. Okay, there's a special button in calculators that help us figure out what a slope ratio is. Okay, so grab your calculator if you don't already have one. Calculators on your phones also have this capability as well. Remember our slope ratio of 28 degrees. Let's move this to 28. Our ratio for that, we said, was 0.531. Well, that is a number that's also stored in our calculator. Okay, so on your calculator, you are going to locate this tan button. Tan is short for tangent. And tangent is a special type of ratio, and you'll see that here. A special type of ratio where we're basically dividing two sides by each other in a right triangle. So go ahead and locate your calculator, find the button that says tan, T-A-N, and then you're going to put in tan 28. And you should be getting the identical number to this number right here. And I'm going to put that value here. It was approximately, because we are rounding it, 531 will round to 532. Okay, go ahead and try that in these two as well. I'm going to open up the Desmos Scientific Calculator. and show you where to find it. Like if you're wanting to use the Desmos scientific calculator, no, let's click on the function button. That's where it is. And then you're going to click TAN, T-A-N. And actually, even if you're not on that, if you go back to the main, if you type in TAN, you should be able to do that as well. Type in TAN 28, and it'll produce that same decimal for you. So you'll notice here, we've got that same exact decimal. Sorry, my face is in the way here. We've got the same exact decimal that we have for a slope ratio. Okay. Now, the one thing you want to make sure, now if you type in tan 28 and you're getting this negative answer here, well, that is what we call radians. So there's different ways that we can measure our angle. We're measuring it in degrees. So right now we're working in degrees. So you want to make sure your calculator mode is set to degrees. Make sure you ask your teacher if you're getting the wrong answers here. On these calculators, if you have the yellow ones, let me grab one of these for you. You're going to want to find the button. There's a mode button on your calculator here, mode. If you push mode, you are then going to want to make sure that degrees is highlighted. We don't want radians, so degrees, okay? A really good way to test your calculator to make sure it's in the correct mode is tan 45. Remember, our slope ratio for 45 is always 1. And when I put into my calculator tan 45, I should always get that value 1, okay? So now, instead of using slope ratio tool, so we don't need this anymore because we have calculators way more readily accessible to us, we are going to use a tangent ratio. And instead of calling it change in y and change in x, because we don't always have it set up as a slope triangle, that it's oriented in this fashion here, sometimes it's going to be rotated around, we are going to start calling change in y the opposite leg. So write that into your diagram here. And we are going to call the change in x the adjacent leg. Because remember, this is a right triangle. In a right triangle, we have two legs. The legs come together and they form that right angle. They form an L. You can almost see it. And then our hypotenuse is directly across from that right angle. Okay, so we're going to practice identifying the legs in our diagram here. I would recommend making this the legs bold or highlighting them with a highlighter. We want to create the letter L to make the legs. So we know, okay, these two sides, these are the legs. They form the L. They form the right angle. Got our leg and we've got our leg. And you can make a note to yourself. Legs form the right angle. So it's going to make an L in some fashion, right? An L or an upside down L or a rotated L. So these are the legs. Now we want to say, okay, an opposite leg is across. It's not next to. Adjacent leg is next to. So we're going to identify these on the diagram. So here's our slope angle, or our tangent angle, we'll call it. And this is the leg that's next to it. So I'm going to call this an adjacent leg. You can write out the full word adjacent. I'm just abbreviating this. And then this is the leg that's across from. It is the opposite leg. Okay, go ahead and do that for the rest. Identify the opposite and adjacent legs in the last three triangles here. Okay. And now that we've practiced that, we are going to start using our tangent ratio. So first step when we're looking at these problems is, okay, here's our angle. It's 26 degrees. We know these two sides are the legs. The leg that is next to 26 degrees is this side. That is the side next to my angle 26 degrees. I'm going to put an A next to that for adjacent. So A equals adjacent leg. And in order to be adjacent, because technically this side's next to, it's adjacent, but it's not a leg. Remember, it's a hypotenuse. So A is for adjacent leg. And then O is going to be opposite leg. And if you want to write out the full words, you can too. So this is the leg that's across from. We're going to call that opposite. And remember, a tangent ratio, tan is opposite over adjacent. So I like to do an arrow diagram, opposite over adjacent. Okay, let's look in our next diagram. Here we have our legs. I always like to identify the side next to it first. So this is next to, that means this is opposite, opposite over adjacent. Let's try one more together. Here's my 57 degrees. This side is next to it, adjacent, and this is opposite, opposite over adjacent. Okay, so x is not always going to be in the numerator. Sometimes it's in the denominator. Really just depends on where it's located in relationship to the angle. So that is your first step for all of the problems. Identify opposite, adjacent, opposite, adjacent. So remember, our ratio is that opposite over adjacent, or we called it change in y over change in x. So we're going to put x over 20, and then we're going to equal it to, instead of using our slope ratio tool, we're going to use our Desmos calculator, or you're going to use a calculator that's next to you, and we are going to do tangent of 26, so tan 26. And we're going to write down this decimal. 0.487 is going to round to 488, 488. Over 1. Again, we can do a cross product for this. X is going to multiply to 1, and 20 is going to multiply to 0.488 approximately. And then I'm going to have an approximation for that because we rounded our answer there. Okay. I would go ahead and try A, B, C, and D, kind of following the same format that I did here. So pause the video, work through that just a moment. Okay, now that you've had a chance to practice it a little bit more, I'm going to show you another triangle here. And I'm just going to show you a different way to format your answer or to format your work. Okay, so we've got two sides here, opposite and adjacent, right? Now this side is next to 31 degrees, adjacent and opposite. Remember, our ratio is always opposite over adjacent. So we're going to say x over 39 is equal to, and instead of looking up what the tangent of 31 degrees is, I'm just going to write tan 31. I'm going to put that over 1. Okay. And oops, I flip-flopped this. Opposite over adjacent. I knew something was wrong there. Please fix that, unless you already noticed it. Opposite over adjacent. Okay, so now from here, instead of having a decimal right here, I'm just writing tan 31 because that's actually a more accurate answer, right? I'm going to do my cross product. Now x, I normally would multiply with that decimal value. I'm just showing that they're being multiplied here using parentheses, and then we end up with 39 times 1. Now, in order to get x by itself, we normally would be dividing by that decimal, but here I'm just going to divide by tan 31, divide by tan 31, and so x is going to equal 39 divided by tan 31. So let's see how we would put that in a calculator. 39 divided by, let's do divided by tan 31. Let me move myself here. And we're going to get 64 something. Now, alternatively, we would have figured out, okay, well, what's tan 31? Okay, it's this 0.601. 600 would round to 601. And then I said, okay, let me take 39 and let me divide it by 0.600 or 601. So we're really getting the same answer, but I would say that the answer that we have here, where we did 39 divided by tan 31, is more accurate because when you start rounding your answers earlier on, that's going to make your answers later on less and less accurate, okay? And we just kind of saved ourselves a step. We don't have to write out this decimal value. We're just writing it as tan 31, saving a step there. So we got, I don't even remember what we got. We got, and I'm going to go with this one here that's a little more accurate. 906 will round to 907, 64.907. And oops, I'm going to put approximately 64.907. Okay, and I'll do one more example with you where this is adjacent next to, this is opposite, opposite over adjacent. So we're going to set this up. as x over 32 equals tan 15. And I'm going to put that over 1. Now, I did notice as I was working on this in class with students that the calculator, tan 15 came out as like a weird funky number on your calculator. And I'll show you really quick. But since right now we're not getting the decimal value for it, but you'll notice, I'm getting that. Anytime that happens, you can push these two little arrows and it'll turn it back into a decimal for you. So if you're preferring to put the tangent value, you can use that tangent value by pushing that and you can get the decimal. Or we can skip that step because we're not writing out the decimal of tan 15, we're just multiplying it by tan 15. So all in one step in our calculator, we're just going to multiply 32 with tan 15. So let me clear this 32 and let's multiply it with tan 15. And that's going to give us 8.574. We'll stay 574. 8.574. Okay, so classwork is going to be finishing up everything here and on the next page. I would say on question 6, we're going to round to the nearest whole number for both of those. And then on question 7, you are going to be using Pythagorean theorem to solve for this. And then on the last question, I want you to explain why you cannot use tangent. So can't use tangent because, and I want you to explain, so then you're going to finish that out, and then I want you to explain why you can't use Pythagorean theorem. Okay, and next week in class, we will be looking at, if we can't use those two tools, what is a new tool that we can use to solve for it?